Every manufacturing process involves a series of constantly recurring operating steps. Workpieces must be loaded, clamped, machined, or conveyed on to the next station, always in exactly the same way. When performed by muscle power alone, these operations become tiring and time-consuming. That's why jobs of this type are more and more becoming a thing of the past. Mechanization and automation have become key words in industry today. They both refer to using the right kinds of machines and equipment to relieve personnel of strenuous routine activities. In this experiment, the cylinder is not capable of raising the load. Not a problem for the left-hand cylinder, even though the same working pressure is being applied to both. The reason is that the left-hand cylinder has a larger diameter. This experiment shows the same thing again. At an identical working pressure of 600 kilopascals, this small cylinder, with a piston diameter of 16 millimeters, registers about 106 newtons on the scale, whereas the larger 25 millimeter piston exerts a force of about 262 newtons. And this cylinder, with a piston diameter of 32 millimeters, exerts about 420 newtons. This can all be reduced to the formula force F is equal to the surface area of the piston times the operating pressure. An atmospheric pressure PAT prevails over the entire Earth. Although the pressure varies slightly due to geographical and climatic conditions, it's taken as a reference parameter and for technical purposes set at 100 kilopascals or 1 bar. Any higher pressure is described as gauge pressure PG. This pressure is normally indicated by the pressure gauges of pneumatic systems. Pressures lower than 100 kilopascals are described as vacuum PV. Pressure P absolute is calculated beginning at zero pressure. A single-acting cylinder is made up of the following component parts: the base cap, the bearing cap, the cylinder barrel, the piston and seal, the piston rod, and the return spring. A distinction is made between the piston side and the rod side. There must be no pressure buildup on the rod side during the forward stroke, which is why there is an exhaust hole in the bearing cap. These single-acting cylinders are being used for clamping. And this cylinder for ejecting. The compressed air, which heated up during compression, is cooled in the compressed air receiver. The resulting condensate is drained off. And now to the second type of cylinder, the double-acting cylinder. Unlike the single-acting cylinder, it has two compressed air ports. Compressed air moves this piston in both directions, which means that double-acting cylinders can perform work on both the advanced and the return stroke. The force exerted on the return stroke is less than the force on the advanced stroke. This is because the effective surface area on the rod side of the piston is reduced by the area of the cross-section of the piston rod. Because of the weight of this tool, work has to be done on both the advanced and return stroke. Here we need a double-acting cylinder. Now let's take a look at a few special types of cylinder, all of which are derived from the double-acting cylinder. For example, cylinders with double-ended piston rods. Two-point bearing support makes for precision rod guidance and greater lateral load-bearing capacity. In this cylinder, the partial vacuum needed for a suction cup is supplied through the hollow piston rod. This cylinder has no piston rod at all. It's connected by permanent magnets to the outside of the cylinder barrel. This way, the slide moves whenever the piston moves. Rodless cylinders can be used for extremely long stroke lengths of up to 10 meters. Another special type of cylinder is the multi-position cylinder, which consists of several double-acting cylinders joined together. The one shown here has two sub-cylinders with different stroke lengths, making it possible to move the workpiece into 4 different machining positions. If a rotary drive unit is needed, the cylinder's linear motion can be converted mechanically into rotary motion. If this conversion takes place within the cylinder itself, we speak of a rotary cylinder. The piston rod of a rotary cylinder has a tooth profile that drives a gear wheel. This handling device uses a rotary drive, with the rotary motion being produced at the center of the cylinder. Now let's take a look at the product of volume and absolute pressure. This container holds 2 liters of air subjected to an atmospheric pressure of only 100 kilopascals. 2 times 100 equals 200. If we compress the air to 1 liter, the pressure is doubled to 200 kilopascals. 1 times 200 equals 200. If we compress the air even further to half a liter, the pressure rises to 400 kilopascals. The product of volume and absolute pressure always remains the same. Smaller forces and compact dimensions are needed for this screen wiper on a CNC machine. Here's another pneumatic rotary drive that has proved to be effective, the rotary vane cylinder. In a rotary vane cylinder, the energy of the compressed air is converted directly into rotary motion. The compressed air acts on the rotary vane. Here a rotary the force to the drive shaft. The rotor acts on the rotary vane. The rotary vane transmits the force to the drive shaft. Here a rotary vane cylinder is being used to power a swivel arm, and here for turning workpieces. This pneumatic screwdriver is powered by a vane motor. One important advantage of the vane motor is that despite its small dimensions and low weight, it still has a relatively high power output. Rotational speeds usually lie between 3,000 and 8,000 revolutions per minute. An eccentrically mounted rotor runs in a cylindrical chamber. The sliding vanes on the rotor form pressure chambers of varying size. Compressed air flows into the smallest chamber and sets the rotor in motion. As the chamber increases in size, pressure drops and the air can escape into the atmosphere. Vane motors can be designed to run clockwise, counterclockwise, or with a changeover function. At this workstation, housings are being screwed onto electric motors. The two screwdrivers are powered by vane motors.